Welcome to another exercise in this workbook, Statistics. This time I'm going to talk about measures of dispersion, and in particular measures of dispersion for classified data sets. So here I have the following two data sets. They're just without any information what is measured, so we simply go on with just using the numbers or absolute frequencies we have. And our task is to calculate the corrected sample variance and the respective standard deviation. So let's start with the first one. So I'm simply going to copy this table and I'm going to add two additional columns here. The first one is the relative frequencies, which is just added up all of the different absolute frequencies and each of the absolute frequencies divided by this sum, by this number of observations, giving me these relative frequencies. And then in the final column, I'm going to add my class means. What do I mean by class means? Class mean, that's the value in the middle between lower and upper bound. So here the value exactly between 100 and 150 is 125. The value exactly between 150 and 175 200 is 175. So I could simply add those two divided by 2, giving me all these values. Because once I have these two columns, I can easily go on with the first step in calculating the variance, which is giving me or getting me the arithmetic mean. Because the arithmetic mean, in this case, is nothing else than here my class middle or class mean times the relative frequency. Doing this for each of the different classes and adding up all the results. That's what I did here. Those are my class means, and I'm going to multiply them with the relative frequencies. That's those values here. Doing this for all classes and summing this up in the end. So finally, I get an arithmetic mean of 433.3075. This one I'm going to need in my next step when I'm going for the corrected sample variance. Here at the first part, I'm going to do more or less exactly the same. However, instead of using the class means, those values, I'm going to use their squares. So here, class mean to the power of 2, class mean to the power of 2, class mean to the power of 2, and so forth. Since this is relatively large, if I would do this with the relative frequencies, here I use the absolute ones and I'm going to divide this by the number of observations. However, you could also go take this one, multiply this with 0.2. Take this one, multiply this with 0.3615. Take this one, multiply with 0.1846 and so forth. So this first part here, the first bracket and this 1 divided by number of observations, that's the average of x squared. This is the average of x, so this line is just above the x. If I have a squared below the line, but above the x, that's what we're going to calculate here. So that's the average of x squared, and we're going to subtract from this the average of x to the power of 2. So having the 2, the square above the line, that's what we get from the formula. Then we get those large brackets. Those large brackets, that's actually my uncorrected variance. So if the task would have been about calculate the variance, calculate theoretical or uncorrected variance, we simply only would have to do what is in the large brackets. Since we have the corrected sample variance, we have to multiply this with this correction factor, which is nothing else than number of observations divided by number of observations minus 1. So 130 observations divided by 129, giving me in total a corrected sample variance of 177 point something. That's almost everything I have to do. Well, I have to go on with the standard deviation as well, but since this is also the corrected version, I can simply get the square root of the variance. Because if I'm using corrected sample variance and corrected standard deviation, I'm going to use exactly the same. I do not have to do any corrections here anymore. So if I'm going to apply this to that value, I will get as an end result 421.6976. That's my standard deviation for my first data set. And this already concludes this first part, this first data set. We got as an intermediate result the arithmetic mean, use this to get the sample variance and then the sample standard deviation. Now we're going to do exactly the same schematic for the second data set. So we're going to copy the same table from the exercise. We're calculating relative frequencies. We're going to calculate class means. And we're going to use them to calculate the arithmetic mean. Again, simply class mean times relative frequency, class mean times relative frequency, and so forth, and adding all of this up, giving us at this point an arithmetic mean of 835 point something. That was the first intermediate step. Now we're going to use this mean again to calculate the sample variance. Similar fashion as before, we're doing the same thing as with the mean, however with the class means squared. That's those values here. And well, here again I'm using absolute frequency inside the brackets and then divide by number of observations. You could, if this is easier for you, also replace this with relative frequencies, but then leave this part. We're going to subtract from this first part the arithmetic mean to the power of 2. That's this part here. This is the uncorrected sample variance. So we need the correction factor, number of observations divided by number of observations minus 1. So 170, 169. Giving us as the final result this part here. Then we're going to use this in the final step to get the standard deviation, the sample standard deviation, by just getting the square root of this result, which is just the 830.4358. And well, that's already everything there is. However, if you want to compare part A and B, we do not know whether those classes are actually measuring on the same scales. So just comparing means, variance and standard deviation would not be feasible. You would have to calculate instead the coefficient of variation for both parts, which would just be standard deviation divided by mean. And those ones, because the mean is in the unit of this part, this is in the unit of this table, so the units cancel each other out, and the coefficient of variation is without any units, and measures without units can be compared across data sets. Not so much the standard deviation, mean, or variances. Well, this concludes the session, so I hope you enjoyed it. I say goodbye and see you next time.